So I stumbled across this study yesterday. It's a new paper published in the Proceedings of the National Academy of Sciences that proposes an addition to the missing law of nature. So this was actually quite thought-provoking. A lot of the studies that I read and then report on, or the sources that I find the studies through, they've not provoked me as much as this one in particular. Like, this actually changed, like, it's made me think about the way the universe and the laws that surround it. They made me think about it differently. The paper proposes that the definition of evolution shouldn't be exclusively thought of as a Darwinian or specific to the evolution, shouldn't be thought of as Darwinian or specific to the evolution of life, and should be thought of more broadly, or as the paper describes, the macroscopic laws of nature. So natural laws, we have like laws that have been established by like Einstein, Newton, and etc., etc. So the laws of gravity, electromagnetism, energy, thermodynamics, etc. So what this group of 9 researchers are proposing is that evolution should be added to that mix of the natural laws of the universe. The authors coined the term law of increasing functional information, which states that a system will evolve if, quote, many different configurations of the system undergoes selection for one or more functions, end quote. The team pointed to examples such as the evolution of minerals across the timeline of the solar system. At the beginning of the solar system, there are an estimated 20 minerals, but over the course of 4.5 billion years, there have been more than 6,000 identified. So that's one example of how, if you have a collection of different configurations inside of a system, and it's complex, that initial system is complex, over the course of time, it will evolve into an even more complex system. And another version of that would be this same evolutionary process takes place in stars, which originally formed from 2 main elements, hydrogen and helium, after the Big Bang. Within these stars, the hydrogen and helium formed 20 heavier and more complex chemical elements, so on and so forth. So the Darwinian perspective is life. Is that like...
yeah, like how we think of it, of like, humans evolving from,
single cell organisms into multi-cell, but Charles Darwin only looked at it as like reproduction. Mm-hmm. So this group of scientists are suggesting that evolution is all around us. It's not just in life itself. Is that if you leave a complex system full of, let's just say elements, pardon me, that system will evolve over the course of time and create an even more complex system. It's like one of the natural laws of the universe, or at least what this group is suggesting, is that evolution is widespread across the universe. It's not just on Earth itself. So this is just some of a quote from the co-authors here. We contend that Darwinian theory is just a very special, very important case within a far larger natural phenomenon. The notion that selection for function drives evolution applies equally to stars, atoms, minerals, and many other conceptually equivalent situations where many configurations are subjected to selective pressure. So this natural phenomenon of evolution only occurs when there is pressure on the initial system itself. So say, take inside of a star, the like hydrogen and helium, they become more pressurized, and then through that pressure, more heavier elements are developed, etc., etc. On Earth, it would be like the environment dictating whether life survives, and then life adapting and evolving to survive. That would be the pressure on that system. Say the minerals in the ground, you've got the way the Earth moves, tectonic plate shifts, a lot of like, or you can even have water and moisture. Like again, the environment under that and the pressure, literal pressure as well, from being so far underneath the Earth's surface, combines and creates things like diamonds and different types of minerals, etc., etc. In this new paper, we consider evolution in the broadest sense, change over time, which subsumes Darwinian evolution based on the particulars of descent with modification. The universe generates novel combinations of atoms, molecules, cells, etc. Those combinations that are stable and can go on to engender even more novelty will continue to evolve. This is what makes life the most striking example of evolution, but evolution is everywhere. What do you think about that? That literally, I had my eyes opened. It made me think about the universe in a different sense, from a different perspective.
I agree. because evolution, we kind of think of it in a closed sort of like, within Earth and life on Earth sort of perspective. You know what I mean? Like if you just say the word evolution, you think about animals and, birds and everything that's evolved over generations and millions of years or whatever the case is here on Earth. You don't think of it at the, the atomic level or stars or the universe or how our solar system and how evolution, I think like when you first said there was that line about 20 materials becoming 6,000 or 20 minerals becoming 6,000. Like it adds credence to the fact that it is as important as every other law of nature in the universe that we think of, is that evolution is integral to everything.
Yeah, it's a part of the study that I was looking at. It's like, this isn't, widely accepted just yet. This only just came out, but it's a very thought-provoking piece. And one of the aspects that they say in the report is that it agrees with the laws of thermal dynamics as well, which I just want to make sure I get right here. Thermodynamics. The laws of nature, motion, gravity, electromagnetism, thermodynamics, etc. codified the general behavior of various macroscopic natural systems across space and time. The law of increasing functional information, which is what the team suggested, complements the second law of thermodynamics, which states that the entropy, in brackets, disorder of an isolated system increases over time, and heat always flows from hotter to colder objects. So there is parts of this that fall into the natural laws that we know today. And I really enjoyed thinking of the universe as a whole as constantly evolving. You kind of think of it more like a, not so static, because static would mean that it's not moving and everything obviously is coming out of that big bang.
So basically it's taking like evolution and that idea of like selection or natural selection, and it actually applies to everything, because it saying that it's a missing law of nature means that yes, it applies to everything, which is pretty like it recontextualizes a lot of how you view things.